Okay, good afternoon. So I suggest to start this session with the hope that people will come. So it's my pleasure to chair this session. We have three talks and then a panel. And let's start by the talk from Pablo Valerio from EETimes.
Hello, good afternoon. Well, I hope we had some coffee this afternoon because, you know, this is the kind of late in the afternoon, and of course we had lunch before, and it's a little bit, we want to go home right now. So anyway, what I want to talk to you is about supply chain, manufacturing, and the rise of bespoke silicon. And one of the things that has been happening in the past few years is because of the requirements of AI and cloud computing and high performance, there is a big trend for, let's say, major companies to develop their own microprocessors, their own silicon, and not just use off-the-shelf products. So as you probably know, a lot of companies are actually just developing their own systems, their own CPUs, and the idea is that they can basically do exactly what they need and manufacture the way they want and increase performance and increase the reliability of the product and lower the total cost of ownership, especially for cloud and now mostly for AI. So especially the hyperscalers and AI are investing heavily in bespoke silicon to gain competitive edge. In reality, in the past, let's say, 5 years, and I'm going 5 or 10 years, but if you look at the last 5 years, ARM, you know, I don't want to talk too much about ARM here, but basically they're eating the x86 market. So not only on mobile, which basically they already had close to 100% market share, but now, you know, in the past few years, they are basically mostly in all the Apple laptops and all the other products, but at the same time, they are now increasing their presence in data centers. While something like in the 2020, they had only 10% of the let's say, data center market, and especially for cloud, now they are close to 30% and rising, okay? So RISC-V, I believe, has a very big opportunity here because of the architectural diversification in a way that, you know, there is a hole in the market, and there is actually market for everybody. If we look at right now, companies like Amazon, Google, Microsoft, Alibaba, Apple, all of them, they are using ARM architecture mostly for the CPUs, but they are starting to use RISC-V for certain particular products and for certain applications. So I'm not going to just to give you, you know, basically an overview of RISC-V because everybody here knows about it. So I'm just going to go a little bit more into supply chain and the challenges that we have with that. As basically we saw this morning, RISC-V is growing very, very fast, but at the same time, the biggest issue is the manufacturing and supply chain. One of the problems that we have is basically we do have 2 single points of failure in the world. It's actually Taiwan and South Korea, TSMC and Samsung. Basically, the fact that about 100% of the leading edge manufacturing is happening in those places is really not only a problem, it is a supply chain nightmare. And right now, especially for the geopolitical issues that it actually is creating. So we need more factories, we need more support, we need more open architecture in order to have a better supply chain, a more resilient supply chain all over the world. So the problem, and probably the biggest problem here, is the fact that we have, just have a look at this. This is the revenue on everything in semiconductors today. And I'm not talking about only high-end processors, I'm talking about everything. So we're looking at TSMC with a 67% of the market, followed by Samsung, and then others. The only people that are actually growing in terms of numbers is actually MEng in China. Of course, RISC-V is the open alternative. It's cost-effective. It's basically modular. You can do everything you want. You can basically create AI processors, HPC processors. You can have it for automotive, for a lot of different things. And basically the idea, and actually we had several talks that basically said that, it offers nations a path to semiconductor sovereignty. And this is one of the things that the Chinese are doing, and they're doing it big time. Okay? So what do we have right now in Europe? And this is what we have a problem. And we have a real problem, especially because of the lack of, advanced manufacturing happening here. And we are not investing a lot. When we're looking at the European Chips Act, with basically 43 billion by 2030, I mean, the original idea or the original numbers that the European Commission were putting into this, they were saying that they wanted to have 30% of the 30% of the manufacturing by 2030 happening in Europe, or processors. Just a couple of months ago, or maybe 2 or 3 months ago, the European Court of Auditors, they said that with luck, we will get less than 12%, about 12% of that. I don't believe that number. I think it's even less than 10%. Why? We don't have the fabs. We don't have the foundries. And this is a very, very big problem. Even if we start building it today, we won't have a leading-edge manufacturing in Europe at 2030. It takes more than 5 and probably more than 7 years to have a factory up and running that can do that kind of a job. So we have projects like, we have DAR, we have the European HPC, all these kind of things for designing processors, for making it, available. That's possible. But where are we going to build them? Where are we going to manufacture them? Actually, even in the US, they cannot do it basically in volume. Intel is actually now separating their foundry from the rest of the business, and they're probably going to have some leading-edge manufacturing going on in a couple of years. Not to compete with TSMC, but basically, I'm going to skip this. We already know these things. This is just for the things that we know that we need to achieve full technological sovereignty through the RISC-V. But we need access to advanced manufacture. So the fastest growing RISC-V adoption is what is actually happening. It's happening in China. And the Chinese are really investing a lot of money into that. We are not doing our job. The numbers are very, very clear. I mean, TSMC is actually building a factory together with some European semiconductor companies in Germany, which 70% of the shares are TSMC, and then 10% for NXP, 10% for Infineon, and another 10% for Nordic Semiconductor. But what is this factory going to make? Chips for cars. And they don't need leading-edge nodes. Even if ASML is a European company, most of everything they build is already sold and is not coming here. I mean, especially the EUV machines are not coming to Europe. The only Intel has delayed their factory in Europe until 2027, and probably it's going to take even longer. So where are those factories, or who's investing, and where do you think the next factory is going to be outside of China or outside of Taiwan, Taiwan or even the US? Probably in the Middle East. They're investing a lot of money and they're trying to attract manufacturing there. They have sand and they have money and they have oil. The other problem in the supply chain is basically access to materials. And many of the materials that are necessary to build semiconductors are controlled by the Chinese. So Europe, we have a problem, a very big problem in terms of supply chain and manufacturing. So we really need a real European strategy, but not just political. We need, the European manufacturers to come together and just realize that this is critical. It is basically a security, an European security issue, and we need to move forward with these things. So I think I took just a few minutes because I want to have time for some questions. So please go ahead and ask questions. Thank you.
Yes, thank you, Pablo. So we have time for questions. I don't see anything from here.
Yeah, regarding just now the security, the supply chain security, right? I think as European, I would think if we decided to move onto the Chinese way to force their later on, we're saying that majority of the silicon has to be made in China. That's one way, right? Because they always have a reason saying that it's a control plan, free markets, this in China. But in Europe, we always have a principle of ourselves, free market. We want it to be absolute free market. That means that we can't put tax on Apple, right? Apple, how much money they earn from us, right? They earn at least 20% of the market from European, right? If we can, against our own principle, say, sorry, Apple, from now on, your chip has to make in the TSMC in Germany. Sorry, you have to do it. But that's really hard for a politician to make the decisions because against our own democracy, free markets, all these principles. And you have one side of the security, supply chain issue. You have one side against our evilness to become a control free market. So I don't know, at the end, I don't know where to go, We're confused.
Well, as I said before, I don't believe it is possible for Europe within the next 5 years just to create factories for, advanced semiconductors in time for 2030. Maybe for 2035 we can do that, but we have to change the way we do business in this case. One of the issues, if you look at the hyperscalers, and we look at things like big technology companies, we don't have hyperscalers which are truly European. I mean, if we look at, for example, basically we're looking at Amazon Web Services, we're looking at Microsoft, we're looking at IBM, we're looking at Apple even as a cloud provider, we're looking at Meta, that are doing a lot of work with AI. The problem is that all of those are American. And then if you look at the Chinese, you have Alibaba, you have Baidu, you have Huawei, and those guys are in China. So what is basically the advantage for them to try to manufacture something in Europe? Well, I wish somebody will tell me that, because I don't know, okay? Unless we change the way we do business and we tell them, okay, you want to have, for example, Microsoft or Amazon, you want to have now a region in Europe, you want to actually create data centers here? Okay, well, we do like the movie industry. From now on, every year we do 10%, 20%, 30%, something like that, and you say you have to manufacture your products here, including the semiconductors. Something like, doing some kind of tariffs as well. Maybe we have to copy a page from the Trump administration. That will be a way to do it. But otherwise, they don't have anything. And we don't have anybody here doing the same that can compete with them. So this is one thing. But the other thing is, I believe there is the possibility, because we do have big semiconductor companies in Europe, especially in the security area, especially in the automotive. But we have to make like a European plan that the industry really needs and wants to do this. And not just because we have politicians that they, okay, we have a CHIP Act. We're going to invest 43 billion euros. Sorry, that's not going to work in the short term, okay? There is the community, there is the talent in Europe, which is very, very important. We have the need, and there is basically, the strategy should be to get self-sufficient, but we need to add not only self-sufficiency on design, we need to add self-sufficiency in manufacturing and supply chain. And access to materials. Chinese are actually buying everything all over the world in terms of materials, in terms of lithium, in terms of, graphite. They control 90% of the graphite market. So I think this is, we don't know. I don't know the answer. I'm just looking at numbers, trying to see what's going on, okay?
Okay, thank you, Pablo. I think we can discuss this for hours, and I suggest to move to the next talk. So thank you, Pablo, again.